Myself, Raviraj Tikare. Today, I am going to present our project PPT for automated diabetic retinopathy detection using deep learning. So, this project is done by Raviraj Tikare, Vedant Puri, and Ajay Ingre from the School of Computer Engineering. So, these are our contents we will discuss. Let's start with the introduction. Diabetic retinopathy is an eye disease caused by the disease, diabetes. It happens when high blood sugar damages the tiny blood vessels in the retina, which is the back part of the eye. And the problem is that the disease often starts without any clear warning or signs. People don't know they have it until it's already serious or uh, causes vision loss or something. As diabetes is becoming the more common, so checking every patient eye manually is hard and very time consuming, and a lot of time and effort for doctors are required. So we thought, why not technology to help this problem? In this project, we created an AI-based tool that uses a deep learning model called Resnet 152 CNN. It is the pre-trained model of CNN, and it looks at eye images called the fundus images and decides how serious the disease is. And we also built user friendly interface so it's easy for both doctors and the patients. So our goal is to make early detection faster, simpler, and the more accessible for patients and the doctors. So let's move towards the motivation. Why did we choose this topic? Because diabetic retinopathy can lead to blindness if not treated early. It is one of the leading causes of vision loss in people with diabetes. So our aim is to use the high quality eye image of the patient to detect whether person has diabetic retinopathy or not. We want to make a system that can tell the difference between the healthy and unhealthy eyes using those images. This will help in faster screening and early treatment for the patient. So our problem statement is we wanted to build a computer-based tool that can automatically detect a diabetic retinopathy. But it's not just that we also wanted it to tell how serious it is, like levels of the severity, like low, medium, high, very high. It is normal case. If it is a normal case or if it is a more advanced or dangerous one. So this kind of tool can help doctors focus on serious cases and act faster. The main objective of our project is to we want to take an image of the person's retina and classify it as either normal or abnormal. To do this, we use a uh, powerful deep learning model called Resnet 152. It is a pretend model of CNN. This model is very good at recognizing the patterns in image. Our sub-objective is before we give the image to the model, we do something pre-processing. This means we clean and improve the image so the model can understand it better. We also extract the images, like we have performed the feature engineering on the images and created the new features. Important parts of the images that helps in identifying if there is a disease or not. In short, we prepare the images properly, then let the model do classification.
Name is Vedant Bhagatpuri. So now I am explaining the technical concept and the algorithm used. So this slide explains the key concept and technology concept algorithm behind our diabetic retinopathy detection system. So the ResNet 50 architecture, it is actually nothing but the residual neural networks. The ResNet is a deep convolutional neural network. It solves the vanishing gradient problem by using the skip connection. This connection helps us the model learn the residual, which is speed up the stabilized training. The ResNet is perfect for our task as we need the RIP model to capture the complex pattern in the retinal image. So conventional layer. In a conventional layer, these are a core layer of the CNN. They automatically extract the importance of the features like the blood vessels, executes, and the microneurons from the fundus images. In the data augmentation, we use the technical concept like the rotation, flipping, or the scaling, artificially expand our data set. These prevent the overfitting and help us the model generalize the better. In the transfer learning, instead of the training from scratch, we use the Resnet model written on the ImageNet. This gives the model as a strong starting point required for our training images as well as computation power. In evaluation metrics is the actually performance of our project. So we use accuracy for the overall correctness and precision recall for the detecting DR correctly without a false alarm. F1 score for the balance between the precision and the recalls. AUC or RUC measures the performance across the all thresholds. By combining these powerful techniques, our system solves the high accuracy while efficient and scalable. So in the next slide we learn about the dataset and the input from formats. So we focus on the dataset and input preparation. We use the large diverse dataset for the high resolution and the retentional fundus images. In the dataset include different level of the diabetic retinopathy or the mix of the age groups and the demographics. Balance your class for the distribution to avoid bias. Image quality is crucial. Blurry or the low resolution image can lead the misclassifications. So data privacy is strictly maintained following the healthcare regulation like the HIPAA. We also implement the efficient data loaders to handle the large images batches during the training and the testing. So in the next slide, there is architecture. So in architecture, actually architecture of the Resnet block, which is building the blocks for our deep learning model. So first it will take the input. In input block, it will receive the features map from the previous layer. This could be the original image or the feature already extracted. So next it will go to the conventional layer. In conventional layer, these layer are basically feature extractions. So in a 3 by 3 filters, capture the pattern like the blood vessels or the lesions. In the 1 by 1 filter, it is used to adjust the depth or the number of the channel without changing the image size. Then it will go to the batch normalization and the ReLU activation function. After each convention, we apply batch normalization to stabilize the training and the reduce internal coverage shifts. And the ReLU activation introduce the non-linearity, allowing the network to learn the complex relation of the images. In the skip or the residual connection, this is actually core idea of the ResNet. We directly add the input to the output of the conventional blocks. This is called the residual connection. It will allow the model to learn only different or the residual between the inputs and the desired output. This helps us to avoid the vanishing gradient problem and make easier to train very deep networks. In the output, we actually take the mix original of the learned features. We will pass it to the next ResNet block. The block design of the make ResNet highly effective of the image classification, especially when we deal with the complex medical images. It will help us to model learn deep and the features without performance of the degradation. So in the next we will the methodology. It is basically reference software model. In that first we diagram is illustrate the complete pipeline used for the training of the VGG19 based on the model of the retinal disease classification. It includes the diabetic retinopathy, glaucoma, or the healthy retina detection. First dataset. Dataset proceed with the dataset return of fundus images. These images are categorized into three main classes, like the healthy, glaucoma, or diabetic retinopathy. Next, it will go to the data augmentation. In the data augmentation, since the medical images are often small, so data augmentation is applied to expand the diversity of the data. Technical like the rotation, flipping, zooming, and the scaling are used. So this helps us to model generalize the better and reduce the chances of overfitting. So next it will the train and split. In the documentation, data are split into the training and the testing. In the training for the teaching models and testing for the evaluating accuracy. So next it will go to the VGG19 is a pre-trained model. So in the ImageNet, it is used the base model. This is a deep convolutional neural network. They already understand the low-level feature images feature like the age, curves, textures. We apply the transfer learning where we adapt the VGG19 on the specific medical task. In the training phase, we pretend the model like the include further trained on our medical dataset during the medical training. And the model learns to recognize the disease specific features like the miscron phase, hemorrhages, or optic discharges. In the testing phase, the model validates our test plate, measure the performance. Evaluation metrics like the accuracy, precision, recall, F1 score are we used to judge how it distinguish between the three classes. In the output, we final output like the trained optimizer model that can actually classify the input rational image and the healthy glaucoma or diabetic retinopathy. That model can be integrated into the diagnostic system or the GO and the clinical decision support.
With Kajay Ingre and explaining the flow of our project. The flowchart illustrates the step-by-step process developing the deep learning image classification system integrate with the graphical user interface. First step is the start. The process begins with the initializing the pipeline to prepare and deploy the classification model. The next step is to create a database and load the data.
The data containing the label images is created or obtained. The data is then loaded into the environment for processing. The next step is to pre-process the image in the dataset. The image are pre-processed to the standardized name for the model input. This may include in the resizing, the normalize, and format the conversation that match the model's requirement. The next step is load the pre-trained model and make the prediction on the test set. The pre-trained deep learning model, example like Resnet 152, is loaded. Then it's used for predict the label for the test subset and data. Next is the get the IDs of the file images and assign them the labels. Each image file is assigned to the predicted label by matching the IDs with the model output. In the next step, we take the few sample image and classify them. A subset of the sample image is selected and classified using the model to validate the prediction of effectiveness. In the next step, we develop a GUI using TK-Inter. It is a graphical user interface is created using Python. This is GUI allow the user to integrate with the model easily by uploading the image and viewing the prediction. Then we read the input image from the user and pass into the model. Then user upload the selected image through the UI. This image is read and pass the pre-trained model for classification. In the last step, stop. The process concludes after the result is displayed. This is a complete pipeline showcase how the machine learning can be effectively integrated with the user-friendly tools and real-time images analysis. Now we will see the literature survey of our project. The first paper is automatic classification of primarily diabetic retinopathy stages using CNN. The journal we use for the International Journal for Advanced Computer Science and Application. In this paper, the image from the datasets are classified into the two stages. After the removing the noise of the images by using histogram equalization, using the deep learning approach, the system will be then detect the whether the person suffer from diabetic retinopathy or not. Based on the answer where the system will be classify the level of diseases and finally propose solution to the patient. The advantage of this paper is this model is not provide m- more reliable and accurate result, but also save a lot of time and money. The overall accuracy and attendance is 84.16. The disadvantage for the paper is the trained model in this paper has a variation from the real data. The several other models may be designed which offer better result than this model. The second paper is diabetic retinopathy detection. This paper uses image processing for detection of DR server images processing technique, including filter, segmentation, classification, and image enhancement, has been developed for this earlier detection and diabetic retinopathy by the feature of excluded blood vessels and hemographs and microasums. Advantage of this paper is the model developed by this paper is not only helpful for diabetic retinopathy affected by people, but also for use by myeloma and amyloid leukemia. The system attain the higher accuracy even the less number of data set. Disadvantage is the negative AI-based finding may give the PCPs and patient a false sense of security about the totality of their occur status. Overfitting is occurs when the model is learned and the random noise and irrelevant details of the images and data set. The third paper is diabetic retinopathy and detection using machine learning Journal, International Journal and Engineering and Research Technology. This study purpose the machine learning method to extract the three features like excludates, homologates, and macro anemorisms and classify using the hybrid classifier, which is a combination of support vector machine, k-nearest neighbor, and random forest logistic regression and multi-layer perceptron network. The advantage of this paper is after the voting three classification classifier, the testing set result is 82% accuracy. This model provides a better segmentation result. Disadvantage is out of the 49 test sample, only 36 product correct prediction. It produces less accuracy when compared to another paper. Now we see the area of applications. Classifying retina disease using the Resnet model has been several important application in the field of ophthalmology and healthcare. Here are some of the key areas where the project can be applied. First is yearly disease detection, screening the program that is government and healthcare organization can use the automated retina disease classification during the last care screening program for at-risk high population, such as those with the, diabetes. Then patient triage in a busy healthcare setting using the automated classification system can help the prioritize the patient based on the severity of their retina disease A patient with the more critical condition can be seen by specialist more quickly. And then is the research and clinical trials. Research can be used the Resnet models to analyze the large data set of the retina images, identifying patterns and trends and disease and progression. This can be in the development of new treatment therapies. These are some of the references we are using in our project. Thank you.